press the bell icon on the YouTube app and never miss another update.
Namaste children. In our last class we discussed central nervous system. Now we will discuss peripheral nervous system and about reflex actions. So peripheral nervous system consists of somatic and autonomic nervous system. So peripheral nervous system consists of somatic and autonomic nervous system. So again the somatic is divided into, is having cranial nerves and spinal nerves. So there are 12 pairs of cranial nerves which arises from the brain and 31 pairs of spinal nerves which arises from the spinal cord. They control somatic nervous system. Then autonomic nervous system again divided into sympathetic nervous system and parasympathetic nervous system. Sympathetic, see, when normal conditionally it will not function, but when we see while doing exercise there is demand of ATP, more energy is required, so metabolic rate increases. So when metabolic rate increases, respiratory rate and heart rate, everything is going to be increased. So sympathetic nervous system increases functions of our organs when demand increases. So sympathetic nervous system increases functions of an organs when there is demand. Once while doing physical exercise is stopped, the functions has to come to their normal state. That is done by parasympathetic nervous system. It decreases the functions of an organ once the demand is decreased. In that way, autonomic nervous system is going to function. When there is demand increases, then the sympathetic is going to function. It increases the functions of an organ. Once the demand decreases, the functions are decreased by parasympathetic nervous system. This is about peripheral nervous system. Next, we will go with reflex actions. So Marshall Hall discovered, or first time he observed this reflex action. First is the first person to observe this reflex actions. So how we are going to define this reflex action? It is a spontaneous means ನಾವು ಯೋಚನೆ ಮಾಡೋದಿಲ್ಲ. It's a spontaneous, involuntary, autonomic and mechanical response produced by specific stimulating receptor. So reflex action, it can be defined as a spontaneous, involuntary, autonomic, mechanical response produced by specific stimulating receptors. That means it is involuntary in function. It is very short-lived response, very quick response, very short-lived response, and no adverse effects is seen in the reflex actions. Usually these reflex actions are protective. They provide protections to our body. There is no adverse effect seen in these reflex actions. So they are involuntary, spontaneous, autonomic in nature, produced by stimulating some specific receptors in our body. Usually they are protective in nature. Reflex actions are protective in nature and very short-lived response, and will not see any adverse effects in these reflex actions. There are two types of reflex actions. Cranial reflex actions and spinal reflex actions. In cranial reflex actions, reflex actions are going to be completed in the brain. In the cranial reflex actions are going to be completed in the brain. Reflex actions will complete in brain, and no urgency required. No urgency required, and it is in action will be slow. Action will be slow. Example is watering of mouth by seeing good food. By seeing good food. In the spinal, reflex actions will complete in spinal cord. It will be complete in spinal cord. So urgency is required. And it is of faster actions. Example, displacement of leg when it is pinched by sharp needles. When pinched by sharp needle. So that's the difference between cranial reflex actions and spinal reflex actions. In the cranial reflex actions, the reflex actions is going to complete in brain. No urgency is required for these actions, and it is of slower in action. Example, watering of mouth by seeing good food. When we see a good food, the salivation increases. That is an example for cranial reflex action. Spinal reflex actions are very important. Most of the reflex actions are spinal reflex actions. Very few are cranial reflex actions. So in these reflex actions are completed in spinal cord and urgency is required. There is faster in action. Example, displacement of leg when it is pierced by sharp needle. ಅಥವಾ ನಾವು ಯಾವುದಾದ್ರೂ ಬಿಸಿ ಇರೋ ಪಾತ್ರೆ ಮುಟ್ಟಿದ ತಕ್ಷಣ ಏನು ಮಾಡ್ತೀವಿ, immediately we will take our hand. That is all come under spinal reflex action. So this reflex action is nothing but it is a animal behavior. It is a form of animal behavior. When some sense organs are stimulated, we see mechanical response in some other organs without intervention of our will. ನಮಗೆ ಗೊತ್ತಿಲ್ಲದೇ ಆಗೋಂಥ ರಿಯಾಕ್ಷನ್ಸ್, ನಮಗೆ ಗೊತ್ತಿಲ್ಲದೆ ಆಗೋಂಥ ಆ್ಯಕ್ಷನ್ಸ್ಗೆ ನಾವೇನು ಹೇಳ್ತೀವಿ, ರಿಫ್ಲೆಕ್ಸ್ ಆ್ಯಕ್ಷನ್ಸ್ ಅಂತ ಹೇಳ್ತೀವಿ. ಇನ್ ದಟ್ ಮೆಜಾರಿಟಿ ಆಫ್ ಅವರ್ ವಿಚ್ ಅಕರ್ಸ್ ರಿಫ್ಲೆಕ್ಸ್ ಆ್ಯಕ್ಷನ್ಸ್ ಇನ್ ಅವರ್ ಬಾಡಿ ಇಸ್ ಮೇನ್ಲಿ ಸ್ಪೈನಲ್ ರಿಫ್ಲೆಕ್ಸ್ ಆ್ಯಕ್ಷನ್ಸ್. ವೆರಿ ಫ್ಯೂ ಆರ್ ಕ್ರೇನಿಯಲ್ ರಿಫ್ಲೆಕ್ಸ್ ಆ್ಯಕ್ಷನ್ಸ್. That's the difference between cranial and spinal reflex actions. And again, these reflex actions are classified into two types based on the past experience. Based on the past experience, that is conditioned reflex action and unconditioned reflex action. Based on past experience. Based on past experience, reflex actions are again classified into conditioned reflex actions and unconditioned reflex actions. So for this conditioned reflex action, past experience should be present. For the conditioned reflex action, past experience should be present, and example for this is swimming, cycling, etc. Then acquired reflex action ಅಂತನೂ ಹೇಳ್ಬೋದು. So while learning, it is voluntary. When we learn functions like swimming ಅಥವಾ ಸೈಕಲ್ ಹೊಡೆಯುವಾಗ, ಪೆಡಲಿಂಗ್ ಮಾಡುವಾಗ, when we learn it will be in a voluntary function. Once we become perfect, it becomes involuntary. That come under conditioned reflex action. Acquired ಅಂದ್ರೆ ನಾವು ಆಮೇಲೆ ಅದನ್ನು ನಾವು ಪ್ರಾಕ್ಟೀಸ್ ಮಾಡ್ಕೊಳ್ಳೋದ್ರಿಂದ, ಆಫ್ಟರ್ ದ ಬರ್ತ್ ವಿ ಆರ್ practicing this, we are learning this. That's why it is also called acquired reflex action. Whereas in unconditioned, no past experience is needed. So this unconditioned reflex is also, it can inborn antanu helಬೋದು, inborn or inherited. Inborn or inherited. So here there is no need of past experience. Example, sneezing, yawning, etc. So in the unconditioned reflex action, very good example is the newborn. The suckling of nipple by the newborn to suck milk is an example for unconditioned reflex action. ಹುಟ್ಟಿದ ತಕ್ಷಣ ಮಗು ಏನು ಮಾಡುತ್ತೆ, it starts sucking the nipple to get milk. That is a very good example for unconditioned reflex action. No past experience is needed for this. Understood? ಇಲ್ಲಿ conditionally reflex action, a very good example given by Patellar, that is bell and dog experiment. In bell and dog experiment, what he did, ಅವ್ರು ಏನು ಮಾಡ್ತಾರೆ, ಬಿಫೋರ್ ಗಿವಿಂಗ್ ಫುಡ್ ಟು ಡಾಗ್ ಹಿ ಹ್ಯಾಸ್ ಟು ರ್ಯಾಂಗ್ ದ ಬೆಲ್ ಹೊಡೆದ್ಬಿಟ್ಟು ಫುಡ್ ಕೊಡೋಕೆ ಸ್ಟಾರ್ಟ್ ಮಾಡ್ತಾರೆ. ಸೊ ಆಫ್ಟರ್ ಸಮ್ ಟೈಮ್, by hearing the sound of bell, the salivation in the mouth of the dog will increase. Food idokina munchene, without seeing the food, the salivation in the mouth of the dog is increased by hearing the sound of bell. So that is a very good example for conditioned reflex action. Or ಏನು ಮಾಡ್ತಾರೆ, ಫುಡ್ ಕೊಡೋಕಿನ ಮುಂಚೆ ಬೆಲ್ ಹೊಡೆದ್ಬಿಟ್ಟು ಆ ಡಾಗಿಗೆ ಫುಡ್ ಕೊಡ್ತಾ ಇರ್ತಾರೆ. ಎವ್ರಿ ಡೇ ಆಫ್ಟರ್ ಫ್ಯೂ ಮಂತ್ಸ್ ಇದನ್ನೇ ರಿಪೀಟ್ ಮಾಡ್ತಾರೆ. ಆಫ್ಟರ್ ಸಮ್ ಮಂತ್ ವಾಟ್ ಈ ಡಿಡ್, ಬೈ ಬೆಲ್ ಹೊಡೆದ ಮೇಲೆ ಫುಡ್ ಕೊಡೋದಿಲ್ಲ. ಬಟ್ ಈ ಅಬ್ಸರ್ವ್ ದಟ್ ವಿತೌಟ್ the food also the salivation has increased in the mouth of the dog. That is mainly due to conditioned reflex action. That is about the difference between conditioned reflex action and unconditioned reflex action. Then one more question, what is reflex arc? The path of completion of reflex action is called reflex arc. So now draw the diagram of reflex action. ನೀವು ಇದನ್ನು ಪ್ರಾಕ್ಟೀಸ್ ಮಾಡಬೇಕು. See, the reflex arc means the path of complete reflex action is called reflex arc. That reflex arc includes receptors. It includes receptors and then sensory neuron or afferent neuron, and it can include interneurons, relay center, and also it includes motor or efferent neurons and effector organs. Effector organs. The reflex arc includes receptors, sensory neurons, motor neurons and effector organs. This is spinal cord. So there are two types of reflex arc, monosynaptic reflex arc and polysynaptic reflex arc. Monosynaptic reflex arc andre in the reflex arc only one synapse is present. Nodi ivaga this here I have seen the sensory neuron is again divided into two. Here we see only one synapse. So this reflex arc is in the reflex arc where we see only one synapse, that is called monosynaptic reflex. In the reflex arc, if we see many synapses, suppose nodi illi the sensory neuron is in contact with interneuron, here one synapse is present, again between the interneuron and motor neuron one more synapse is present. So if they have more than one synapse, that synapses are called polysynaptic arcs. Monosynaptic arc means they have only synapse in their arc. Polysynaptic arcs means they have many synapses in that arc. But nimge PUge they will ask what is reflex action, what is reflex arc, explain the reflex action with a schematic representation andaga ನೀವು ಇದನ್ನ draw ಮಾಡಿ explain ಮಾಡಬೇಕು. We already know that reflex action ಅಂದ್ರೆ it is a involuntary autonomic spontaneous mechanical response produced by specific stimulating receptors. Reflex arc means the path of completion of reflex action is called reflex arc. And with the example explain madi reflex action andaga you have to explain like this. When stimulus is applied to a receptor, when stimulus is applied to a receptor, even nodi with a hammer en ಮಾಡ್ತಾರೆ they will hit the knee joint. Knee joint ಗೆ ಅವರು ಇಲ್ಲಿ ಇದನ್ನ ತಗೊಂಡು ಹೊಡೆದಾಗ ಏನಾಗುತ್ತೆ, the receptors are going to produce action potential. When stimulus is applied to the receptor organs, in the receptor organs action potential or generation of nerve impulse takes place. That nerve impulse will be carried to the spinal cord through a neuron called sensory neuron or afferent neuron, where the impulse is analyzed, integrated and sent to the effector organ through a motor or efferent neuron, and we are going to see the action in the effector organ. Understood? Listen here, when stimulus is applied to a receptor organ, in the receptor organ we see generation of action potential or nerve impulse. That generated nerve impulse will be carried to the spinal cord through sensory or afferent neuron, where it is analyzed and information to the effector organ is sent by motor neurons and the action is seen in the effector organs. That is about the reflex action. ಇಲ್ಲಿ ಏನಾಗುತ್ತೆ ಅಂದ್ರೆ, see, when the stimulus is applied to the knee joint, The patellar region, receptor, here the upper part of this, it contains quadriceps muscle, and lower it contains hamstring muscle. Stimulus apply ಮಾಡಿದಾಗ ಏನಾಗುತ್ತೆ, action potential generate ಆಗಿ it will carry to the spinal cord. Here you see, I am showing two motor neurons. So one sensory neuron is in contact with a motor neuron. There is no presence of interneuron. Interneuron illa. In this junction, in this synapse, we see the excitatory neurotransmitter. Release of excitatory neurotransmitter is seen between the junction of sensory neuron and motor neuron. There is no presence of interneuron. These excitatory neurotransmitters are going to supply to the quadriceps muscles where we see contraction. One more ending of sensory neuron is in contact with the interneurons, and they release at this synapse, they release inhibitory neurotransmitters. That means the stimulus is not supplied to this. There we see relaxation of quadriceps muscle. ಎಲ್ಲಿ excitatory neurotransmitters release ಆಗುತ್ತೆ, that results in contraction of the muscle. ಎಲ್ಲಿ inhibitory neurotransmitters release ಆಗುತ್ತೆ, there we see relaxation of the muscle. When quadriceps muscle contract and hamstring muscle relax, the leg will move in forward direction. Response is seen in forward direction. This happens in the knee jerk reflex action. Knee-jerk reflex action ಏನಾಗುತ್ತೆ, when we apply stimulus, the receptors generate impulses. That impulses are carried to the spinal cord through sensory or afferent neuron, where it is analyzed. See, it is having two ends. So one sensory neuron which is in contact with the motor neuron, where the excitatory neurotransmitter is released, that will bring contraction of quadriceps muscle. And the sensory neuron which is in contact with interneurons, they release inhibitory neurotransmitters that will supply to quadriceps muscle, lower part of the leg, that relaxes the muscle and the leg will move in forward direction. That means response is seen in forward direction. This happens in the knee jerk reflex action. Understood? ನೀವು ಇಷ್ಟು ಎಕ್ಸ್ಪ್ಲೈನ್ ಮಾಡೋದೇನು ಬೇಡ. ಫಾರ್ ಯುವರ್ PU exam, you can tell when stimulus is applied, it is carried to the spinal cord through the sensory neuron, where the impulse is analyzed and the information is sent to the effector organs to the motor neuron, and effect is seen in the effector organ. The leg will move in forward direction. Response is seen in forward direction. ಇಷ್ಟು ಎಕ್ಸ್ಪ್ಲೈನ್ ಮಾಡಿದರೆ ಸಾಕು. ಇದು ನೀವು ತಿಳ್ಕೊಂಡಿರ್ಬೇಕು, ಹೌ ದಟ್ ಹ್ಯಾಪನ್ಸ್, ಹೌ the quadriceps muscle contract and hamstring muscle relax. Understood? And the cross, when we take transverse section of spinal cord, the spinal cord contain inner gray matter which is H shape, and outer white matter. Adu competitive ಅಲ್ಲಿ ಕೇಳ್ತಾರೆ. The H shape portion of spinal cord is gray matter, outer it contain white matter. This is about the reflex action. Understood? ಒಂದೊಂದ್ಸಲಿ ಡಯಾಗ್ರಾಮ್ ನಿಮಗೆ 5 marks ಕೇಳ್ತಾರೆ, ಬಟ್ when you draw the diagram, arrow mark ತುಂಬಾನೇ ಇಂಪಾರ್ಟೆಂಟ್. Stimulus is applied, arrow mark, and this receptor organ, quadriceps ಅದೆಲ್ಲ ಏನು ಬೇಡ, and this sensory arrow mark ಈ ಡೈರೆಕ್ಷನ್ ಅಲ್ಲಿ ತೋರಿಸ್ಬೇಕು, and motor like this. These are all very important to get 5 out of 5. Understood? Next, intelligence quotient, IQ. IQ ನ ಯಾವ ರೀತಿ ಕ್ಯಾಲ್ಕುಲೇಟ್ ಮಾಡ್ತಾರೆ? How they calculate IQ of a person? That is by using a equation mental age by So, by using this equation, they will calculate IQ. Mental age, they will calculate by intelligence, by seeing their intelligence by doing the different tests. And chronological age, their calendar age means birth date in the calculate matter, that is chronological age. So, by using this equation, mental age by chronological age into 100, they are going to calculate IQ. By getting that, the low IQ, medium and high IQ levels they are going to classify. This is about the intelligence quotient. Understood? Thank you. In the next class, we will discuss about the sensory organs, eye and ear, the structure of eye and the mechanism of vision formation, that we will discuss in our next class.